This graph, let me move this up just a little bit. Because when we analyze the graph, what we want to be able to do is we want to be able to find a degree, because that's going to tell us what the shape of the graph is going to be. We want to know the number of zeros and locations. We want to know relative minimums or maximums and their locations. We also want to know maximum number of turns, which is just formula. And that's a pretty good start for right now. Now the degree here is always going to be the biggest power. The biggest power is 3. And since my leading coefficient is 1, I know that the graph is going to take this look to it. Oh yeah, and behavior. As x goes to negative infinity, what does f of x do? As x goes to positive infinity, that's a horrible infinity, what does f of x do? Well, we can figure out end behavior from here. This is as x goes to negative infinity. F of x, the graph is going to negative infinity. So this is going to be negative infinity. And as x goes to positive infinity here, the graph is moving up to positive infinity, so it's going to be to positive infinity. So you can figure out end behavior just from that idea. Now, when we get into more complicated polynomial graphs like this, the easiest way to do is to jump into the TI or the Inspire and actually graph it out. So we'll have x cubed minus 5x squared plus 2x plus 8, and then we hit this. And notice that I don't see the top of the graph, but we have some turns here. So you can grab the graph and move it down if you want to, or you can change the window. You can grab the function name and move it over to the side. I see all the zeros here. I see a maximum. I see a minimum. So So what we're going to want to do is, I think the easiest way to find the zeros is to open up a new line and graph the line y equals 0. Because now we have the line y equals 0. And if we go into menu, and if you go into points and lines, which is under your geometry tab, and go to intersection points, all you have to do is click on 2 different graphs, and it gives you all of your zeros at once. So I'll escape out of there. I have my 0 at negative 1, I have my 0 at 2, I have the 0 at 4. So I can go over here, and I know there are 3 zeros, and they are located at negative 1, 0, 2, 0, and 4, 0. So just by graphing f of x is equal to 0, we're able to do that pretty easily. Now, maximum number of turns is always n minus 1. So since I know n is the degree, it's 3 minus 1, which is 2, and you can kind of see the turn, it's going up. That's 1 turn, 2 turns. So I got my 2 turns. Now, to get my relative maximums and minimums, hit menu, hit analyze graph. You can get your zeros from here, but you can calculate minimums and maximums as well. So if you calculate a minimum first, the minimum is that point right there. So it asked me for the graph. So I want the red graph. So now I want, as for a lower bound, so I'm going to go to the left of the 0, and then I'm going to move all the way over to the right part of the 0. My point's way off the screen, so I'm going to bring it up here. And I don't care as much about 3.12, but I know it has a minimum at y is equal to negative 4.06, because when I'm dealing with a function value, the x is important, but the y is going to be equally important, or even more so, because I know that's my negative value there. Now, to get the maximum value, we're going to do the same thing. Menu, Analyze Graph, go to Maximum, click on the same graph, and then I'm going to go to the left of the bound of the maximum, go to the right, and you can see we got our maximum value right there. There it is. And my maximum is going to be at y is equal to 8.21. And so now we know everything. We know end behavior. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. We know our zeros. We know our maximum, our relative maximum. We know our relative minimum. We know where the function is negative. It's here, and this little u here. We know where it's positive is this bigger u here. We know it's positive all the way up there as well. And we can add a whole bunch of other information from there as well. So, analyzing a graph is pretty straightforward. It's just finding these special points that we always look for.